Hello guys, what's up? This is Ahmed from Engineering Software Learning. In this video I will show you a useful feature that should you know as a mechanical engineer and also as mechanical engineering student. This is about Catia softwares and especially about the machining workbench included in Catia software. Of course, Catia is a worldwide software used in mechanical engineering by huge and multinational companies like as Boeing, Bombardier, Dassault Aviation, Airbus, Helicopters, Alstom, Goodyear, Yamaha, Tesla Motors, Rotax, also by other sectors, also by huge universities and high engineering schools, especially in France. So in this video it will just an introduction about the machining and especially about the prismatic machining, so don't be worried if you don't understand. I will explain all of these things through a mini videos. This video it will based on the academic courses and what's happened in reality in the factory. So how we do to adjust the machine, what type of the machine that we use to machine such type of the part and so on. Let's start by the milling, and we go to the file. Now we should already design our part. So here we have my part. So okay, this is the type of my part that I should milling. So before that I should here insert a gross part. This is a final part, and I should do a gross part. So just here have a body too. So here we have properties and change the name by the gross part, or okay, gross part, and okay, here we have, and click in sketch. Just simple things in the XY plane, and I do just simple things, just prismatic, and I will the concentric rectangular or centered rectangular here. Okay, just like this. Okay, I should constrain that, and we'll do okay 100. It's okay, just an example, of course. 100. Okay, 100 here also, it's square now, and okay, it's good. After that, should make sure that this square should be the part should be in the square, inside the square here, because this is the gross part, and here we have the final part. So just pad here, and we should give the length, or the length. It's about mirrored extent. No, I will use more because they should different. I have different length here. Okay, just here is maybe 15, and here is just 10. Okay, 10. Okay, and okay, we have that. This one is the gross part, and we should go to the property here. Okay, graphic, change the color and transparency here in order to show the final part here. Okay, so in the part design here is finished, and we go to start, and after that go to the machining, workbench, and prismatic machining. Of course, here we have another user interface. It's the same user interface, but the tools here and the workbench change. We have the prismatic machining now, and this tools is related and depend on this prismatic machining. So before we go to the machining, we just click on the part operation to give to the Catia give the Catia the final part that we obtained after the operation, and here we have the stock or the gross part. So double click here and go to enter the parts, plus here, and click. We can just click on the part body here, or just do hide and double click here. So I prefer to use the tree specification tree, double click on the parts body, and we have these things. Okay, we have two parts here. I should reset and just one click here, and okay, now here we have the stock. It's the gross parts. Okay, and it's okay now. We can click to the safety plane and change this plane one, and now go to the reference machine access system. Click here and click on the position. Okay, here, and choose these points. Okay, we should verify that the access is like that, and click on OK. After that, we should go to the machine and choose the type of machine. Here we have the 3-axis machine, and it's okay. Now go to the numerical control, change the controller, go to the Phonic, not specified, the post processor to Phonic 0 point or dot lib, and here is IMS table and is ISO here, and we can go to the OK. Of course, after through the many videos that I will do after, I will explain all of these things, so don't worry about this choice and so on. Just follow this video and like that, and after that I will show you everything that you will need to do this machining efficiently and related to what happened in reality, similar to what happened in reality. So click now OK, and now the preliminary operation is done, and now we go to the machining. The first operation to do is here is the facing, so to remove the surplus of the material. Just here facing, click here, and OK, click facing and click here, and of course we should go to here to the strategy. Before that, we go to choose the type of the insert. Here we insert here the upper plane. That's related to the stock, and here we have the final plane. Hide this, and the final plane here. After that, we should choose the counter. So click here, and we should go here and show this. Return to our user interface. So, and we should select this whole counter, these edges, 4 edges here, and double click or just click one click here, and we have now all this is green, and it's okay now. We can choose the strategy of the machining. Okay, inward helical, okay, and radial now, radial here, diameter. Okay, I will use more, use this. Okay, and overhang, it's 100. Okay, 100. We should do 100 because we have the surfaces. It's okay about yes, we should do 100, and we will explain why. Here, go to the tool and choose this one, face mail, and just it depends which we should choose this related to the tools that we have, and about these tools, of course, related about the operation, about the type of the material, and the type of the material of the machining part, and also of the tool of the machine, and the capacity of the machine, and so on. Many parameters that we should adjust to be similar to what happened in reality. So here we, for example, we put 20, maybe it's okay. I think here 100, it's just to give one handling to give just a link to this. This one is not useful. This area is what we do the work, and okay, we have already made all. Here we should put the velocity, machine velocity, and so on. It's depend about the machine parameters, and this is related to the tool, to the machine tool, to the materials, and many other parameters that you probably have the idea in the theoretical courses. Of course, we'll handle all of this. We explain the theoretical things about the machining. So here, just click here for the toolpath replay, and to say this, we have this the path. So we have it's good, it seems good. We can do the simulation, and it's okay. Now we click OK, so play, and we see we have the face in here. So remove the surplus of the material of the to give the to get to the final part. And we have this one is the first operation. Now we should hide this because we have already here displaying. Now we do this this remove the matter here. So we use this tool profile contouring, click here and go to this. We use the stock. Okay, yeah, we should click here, it's okay. Here we have the final part, we have the final surface. The final surface is here. This is our final surface. Here we have our start surface, and here we have the target or the path. The path here is this one, so we should select this, all these edges here. So follow the path here. Of course, now we have I have already here this one, and this one here. Okay, it's okay. This one here, and okay, it's about related about the this one here. Maybe I have some problem here. Okay, I will just escape, remove this one, remove all contour, and start. Okay, I do this one, it will be better. So here one, this one. Okay, follow all this path here. Okay, then okay, sometimes we have some problems here. Okay, I think it's okay now. Yeah. Okay, we have just things zigzag. Now we have helix. We do helix, it's okay, no problem. Can, of course, this is depend about the choice of the strategy of the machining. So here we have, okay, I will not touch this, and just I will touch this the end mile. Click to choose the tool. Here we have 10 in diameter. I will keep it. Remove this radius and set by 0. Okay, and now do directly. I have tool must be normal to the plane. It's okay. It's about the final. So remove this plane and remove this plane, and start and select again this plane. So select this one as a final surface, and this is the begin surface, and choose this one. Okay, I still have the problem. This is the same problem. It should start again. So just delete these tools and click here, click in this here, okay, then here, then okay, select the first one, maybe select here, it's okay, good. Okay. Sometimes in the machine we have some problems, so we should have the theoretical and background in order to analyze the type of the problems. So it's a good example here to show the problems. Okay, here we have some problem here. No, it's okay. I think the counter is closed. This counter must be closed if we do the helix as path. So it's okay. Yes, it's already closed. Okay, and select as first one. And of course here, if we select the helix, the counter should be closed. This counter path should be closed as the male. So I will choose this 10 and will remove or set this by 0. Other things I will keep it by default, and these things, of course this is when I do the simulation, it will be some problems, because here we have some surplus of the materials of the matter here that will not be removed. It's okay, it will be a good example to show the problems. And here this is okay, since we have the problem here, should remove all this matter here. So it's this about this about the machining here, the parameters. So the distance between the paths is this one. So as we have 10 in diameter, we can put until 9, it's without any problem. And here maybe 3 paths, and yeah, I think it will be okay. Start. Okay, let's we have some here problems, and so we can just put added one. We have 4 numbers, okay, and show we have 4 numbers of the path, 1, 2, 3, and 4, and now it will be okay. Okay, play, and no, I still have some things. Now it will be sure okay. Okay, yeah, it's good now. Okay, so okay, it's closed here. We move to the third operation. It's about the pockets or pocketing. It's in order to do the pocket here. So here is the final surface obtained after the operation. This one is the start surface, and this is the path or the guide. So here we have the final. This is final. Here, of course, by default we have this island detection, and the counter detection is here is checked by default. So in these cases we should deactivate these options in order to get the same things as shown in this video. Go to this to select the first or the start surface, and here we select this guide. So of course the operation will be here inside this hall. So okay, about tools, I will just keep all of these things by default. Just here in tools I will choose another, just here, and change this by 3, maybe 5. I will select 5, and here 0, it's okay, and here change diameter as 5. because here we have diameter of the tool is 5, so tool number 4 and male and diameter is 5. So okay, go to this one. Okay, just here. We have some problem here. So it's depend about the tool. Okay, so I will just put 2 and play. Okay, this is some problems is related about the parts because we don't design the part properly. So here we do some error, and we try to understand the error and to interpret the error through the simulation. Here I think it's okay. Yeah, I think it's okay. Okay, now I think I have some problems here. It's about this hole, the radius of the hole. I will just show you these things. Keep other operation, do the other operations without analyze the error. So after that we'll analyze this appropriately when we do the parts. The part will design the part and enter the right dimensions. Here we have these things. Okay, the same operation will be repeated in the 4 holes. Okay, it's okay. Then we'll do the same things here and return first, and the path is this one. Okay, and okay, and then it's okay. The final hole is the big one, and click here, and guide. Okay, guide is the big circle. It's okay. Now we do the simulation. Okay, the simulation. Okay, I have some problem here, but we don't analyze these things now. Of course, this is, I know that this is, it's because yeah, it's because the tools, it's about these things, the approaches and the retract. We'll adjust these things after. So now we move to this final operation here. For that, it should do these things. I should go to the window part and do this trick. Of course, like this. Select this one and zoom here. First point, second point, and okay. And here, first point, second point, and okay. The same things here. Okay. Okay, I should select point, and it's fine. Okay, still the final operation here to do the lines, 2 lines from this point to this point, and second line from this point to this point. Or this is the point and this is the edges. Now we do the plane. This plane should be through the 2 lines. This is through 2 lines, and okay. This is Catia is smart software. So it's when we select 2, just select plane, and here maybe just offset plane. If you select the first one and the second plane, it's by default will give you a plane through 2 lines. So this is smart interactions between the user and the software. Okay, here and here, and now it's okay. And here's some offsets. Okay, offset just here, this direction, and the other in this direction. And this is because for do these things, okay, cannot do it just I think it's very so we have some problem here. I should remove this, delete, and click here. Okay, and just here for this point. Okay, and from this point, okay, I think I have some problem here. Okay, yeah, now good, it seem good now. And this one, it's should be just here, and I will keep these things like that. Of course we have some problems here, but it's okay now. Just it's the introduction about these things, and after that I will explain all of these things based on the theoretical and what we do in reality in the factory. So here just select this one, okay, and select this first, this last one. I should keep, I have this one here, should put another one. I think it's okay. It's okay, and here it's okay. The counter, this one, all the things, so the interior things. Okay, here, and so I think it's okay now. Okay, should be closed, and okay. Of course we should do some simulation in order to see if the things it's okay or not. I think I have some problem, I think, yeah. Okay, now it's yeah, the problem here, it's this problem, it's about the retracts. Of course I can solve this by just a change of the tool, and it will be changed. That's 0 here, and it will be fine now. This is about the approaching and the retract things, strategies. So here I think it will be okay. No. It's okay, but it's just about these things. Okay, and about 2, and okay, and now it's okay. Okay, it's good, nice. Okay, just here, and deactivate this one, and hit this one, and try these things, and see what will give to us. Okay, yeah, no, it's okay, just okay, we have some problems, but it's okay. All these problems is about just the adjustment strategy that we should do. So here, as because we don't focus on the things, it will be it will have some error here. It's naturally things, the machining, so should do the right things here in order to have the right simulation. and through the simulation we can see the problems, if we have some problems or not, but we should of course have some background, theoretical background, in order to interpret and analyze the simulation, because Catia is give us the simulation, but the user should analyze this simulation in order to verify if there is problems or not. Sometimes there is a little small problems, and this one, it will be a huge problems in the reality when we do the part, if we don't solve this problem in the simulation. When we obtain the G code that we will insert in the machine, I will have a default, a small default, but finally the part, it will be not good. It will be not guaranteed by the control, geometrical control department, and it will be a waste of the matter, and also time and money. Okay, here, so here we have some simple things, some clicks. Here it's okay, it's good, but the huge task doing by the users is the interpretation of the result before going to the fabricating. This is a very huge task, and we should have many experience and huge academic backgrounds about the machining, about the machining tool, about the operations, about the condition, and so on. All of these things should have a lot of experience in order to analyze correctly the results before going to the final step, is to obtain the G code and to insert this in the machine, CNC machine, and or similar to that. And after that, operator will give just a stock to this machine, and click on the start, and the machine will follow the G code, and if all is good, we'll obtain the right parts. If we have some default, so it will obtain a bad part, and it's not good for the factory, especially if we do many parts in the same time, and this is the case in the industry. And like as here we have some problems. This problem, I should solve it now. It's sometimes just axle here and do some 15. It's okay, 15 here and 15 here, user by user axle, and 15 here. This problem is solved just here. And of course we do the same things here. All these things is just now it's just analytically, just for demonstration, but we do the approaches is based on the calculation, is not doing like type any number you like, just by calculation, because all this operation is depend about the time. And when we talk about time in industry, it's similar to the money, and if we have good programs and good optimization, we get good results. This is we have these interactions between the time, money, and the optimization of the processes in the industry. Okay, so here 15 like example, and here we have user by actual, and 15, and click here and do this operation. Now go to the simulation, and Okay, let's try the final simulation here. Same idea. Okay, I will try to slow down the simulation in order to see what is the problem exactly. So just here we have the facing operation now. Now we have the counter operation. Okay, it's okay. Okay, just pocketing. Okay. Okay, so slow here. Okay, that's because we have the change in the. I have some problem in the orientation. So here should change the orientation of the tool. Okay, have some here problem. We have a problem here. Is of course it should be a problem. So okay, remove this and remove this. Have the same path, and we should change this one. Okay, escape here, click here, click in the first one and the second one here, and now we should have the right answer. Okay, and so just demonstration, do it fast. Okay, now first one and second one, it's okay. The third one, it will be the same, just okay. Here it's the okay, remove this, and of course it's better to choose this one, first one, because it gives the orientation of the tool. And click here, okay, the right orientation. If we choose this one first and this one, we have the bad orientation. So here we have the final part. So just a simulation here, and okay, now we can do the right operation. Now we have fast motion, and this one is wide because we don't click here. So we should click here and do the simulation in the last part. And maybe we have the just should analyze these things. Okay, the whole 31, and okay, yes, we have this, we do the same operation here, and here we have the same operation. Notice this. So just here we should just click here, remove this one. Okay, click here, click the first, click here and select this plane, and click here and select this other plane here, and click on the simulation. And now we have, of course we have now, I'm sure that we have the right answer. Just click here. Okay, 1, 2 and 3 here. Okay, of course this is, we have about the dimension here, but it's okay. It's we have the similar parts. That's mean that we should do the similar operation, but we have something wrong in the adjustment in the parameters inside each operation. That's why we have the bad cutting here, and of course we have the bad dimensions here. Okay, I will try the last time based on just slow motion, give you the operation. Here we have the facing operation to remove the surplus of the matter here, and the surplus of the matter here we have the counter. Of course this is depend about the level. We have, I think, have 3 level 1, 2 and 3. Of course, okay, the whole 1, 2 and 3, and the center circle or central hole now, and the last operation. Okay, the same thing we have here. And also we have the same thing here. Okay, so this is all about the prismatic machining. It's just about an introduction. I guarantee that after that I will explain all of the things step by step, and it will be easy to learn and to understand it. Also, it will be through the theoretical courses, of course, and explain you the different type of the machine and what happened in the reality in the factory. So see you next time, and be safe. Thank you.